Good day everyone. Today we will further understand Newton's law through problem solving. I will give an example problem for me to discuss. Here it goes. Suppose you try to move the crate by tying a rope around it and pulling upward on the rope at an angle of 30 degrees above the horizontal. How hard do you have to pull to keep the crate moving with a constant velocity? Assuming that the weight of the crate is 700 Newton and our kinetic friction mu k is 0.40. Given the weight 700 Newton and the initial kinetic friction is 0.40, we also have another data which is the angle 30 degrees. We need to solve for the force or the tension in which minimizing the kinetic friction will be applied. We have written the given data. Next is the free body diagram in which all forces acting along the x and y will be drawn. First is the weight of the crate which is 700 Newton, which is drawn downward because of the gravity applied. Then, the normal force that is always opposite to our weight. The acting force in our problem is tension. Next, the final kinetic friction, which is always opposite to acting force. Based on the problem, the force acting in the system is angled in 30 degrees along the horizontal of the x-axis. But remember, this isn't the exact component along the y and x. We still have to deal with it. We still don't have the component along the y. Thus, we all know that it is the opposite of the angle given. Therefore, it will be solved by multiplying the tension to the cosine of 30. Moreover, to get the x component given that the horizontal is adjacent to the angle, therefore, the x component will be sine the angle 30 multiplied by the tension. We have our diagram, it is easier to determine the components along the x and y. Imposing the first law of motion, we all know that the sum along the x and y should be equal to 0. We will now apply the law of motion. For our first equation, our positive force is the t cosine 30 degrees minus its opposite force, mu k, that will be equal to 0. Our second equation will be the normal force plus our additional component t sine theta minus the crate's weight w. That is expected to equal to 0 also. From those equations, we can eliminate variables. We all know that the kinetic and static friction will be solved using the formula initial friction multiplied to our normal force n. From that fact, we can now move to the mathematics part. From our first equation, we may substitute the formula for kinetic friction, mu k times n equals to 0. From our equation 2, transpose n from the other side to get its formula weight minus t sine theta. Now we have our formula for normal force, we can substitute it from our first equation. Now we have t cosine theta minus mu k times the quantity w minus t sine theta equals to 0. We will notice that in our equation, we can see all the variables given from our problem. We will now work on our working equation to solve the tension force. From our previous equation, we can remove the quantified formula. Let's distribute mu k from that. Now we have t cosine theta minus mu k w plus mu k t sine theta equals to 0. We can notice that there is a common variable t. We can factor that from the equation. We have now t quantity cosine theta plus mu k sine theta quantity minus mu kw. From that factored form, we can divide the quantified formula both sides to get the formula in getting the tension force T. We get the formula mu k times W over cosine theta plus mu k sine theta. We have now our working equation. Using the working equation that we solved, we can now substitute the values that were given earlier to get the force needed. Our mu k is 0.40 times our 700 Newton weight over cosine theta 30 degrees plus the quantity mu k is 0.40 multiplied to the sine of 30 degrees. Just enter the values in the calculator and you will get an answer of 262.66 Newton. And the answer is you have to apply a 262.66 Newton to pull the crate in the constant velocity.